Okay, so keywords we're going to need to know are all of these, and we're going to be talking about all of these throughout our presentation. But two that I want to touch upon really quickly are electronegativity, which is the ability of the atom to attract elements, to attract electrons in a bond to itself. Then also inductive effects, which is just a fancy word for dipoles, and this will affect acid strength as you need a polar bond to release an H plus proton in the water upon ionization. So in this diagram, we can see that as you're going from left to right in the row, acid strength is increasing, and as you're going from up to down, acid strength is also increasing. This has to do because of bond polarity and bond strength. So bond polarity increases from left to right because of the electronegativity increasing of elements from left to right. So the difference in electronegativity increases, the bond polarity increases as well. And because the bond polarity increases, electron density will be going more towards the electronegative element, and this will make the H atom easier to release upon ionization in water. So that is why, as you're going from left to right, the acid becomes stronger. And in covalent and in nonpolar bonds, we can see that as in CH4, it's a nonpolar bond, and so nonpolar bonds have no acidic or basic properties. They can't be acidic because they cannot release the H the H atom in water upon because they have the same difference in electronegativity. So because they're nonpolar. Then as you can see, when you're going up to down, that has to do with acid strength with bond strength. Because as you're going from up to down, what's changing is the atom radius. And as the atom is getting bigger, that means that the bond strength is decreasing. So it's an inverse relationship right here. And you can see that as it's getting bigger, so because the bond strength is decreasing, that means that it's easier for the H to be released upon ionization. And that is why as it gets bigger, acid strength increases. So for binary acids, bond polarity and bond strength are the two most important factors, and then also conjugate base stability. So bond polarity is important because a bond has to be polar in order to release the H atom upon ionization. And as you can see in this picture here, we can see the different dipoles. We can see the inductive effect taking place right here. And because Cl is more electronegative than H, the the electron density is more towards the Cl, and so because there's a high polarity in this bond, it's a very strong acid, and we know HCl is one of the seven strong acids, and this is how we prove it. And so that's how the bond polarity shows. And then the relationship between bond polarity and acid strength is a direct relationship, as you can see. As the bond polarity increases, the acid strength increases as well. And so then with bond strength, however, it's an inverse relationship. This is because as the bond strength decreases, the acid strength increases. And that's because the H will be easier to release upon ionization. And as bond strength decreases, that means that the atom is getting bigger. So that's why when you're going up to down in a row, in a column, that's why acid strength is increasing. This also has to do with conjugate base stability, because we know that a strong acid has a weak base. And one way to tell if it's a weak base, and it's a weak base has the characteristic of being, a weak conjugate base has the characteristic of being stable. And there's three different ways to stabilize a conjugate base. And has to do with electronegativity, the inductive effects, and then also resonance. So electronegativity makes a lot of sense. First of all, because as you're increasing electronegativity, you're withdrawing electrons and the negative charge away from other bonds. And as you're doing this, you're delocalizing the negative charge. And when you're delocalizing a negative charge, you're spreading out the negative charge throughout the entire molecule. And this has a stabilizing effect upon the conjugate base. Inductive effect is the exact same thing. It has to do exactly with electronegativity with the dipoles, and this is only possible with a difference in electronegativity. And you will see with oxyacids, with the OH bonds, especially, how the more electronegative elements that you add, it will withdraw the electrons away from the OH bond, making the OH bond weaker, and thus allowing the H atoms to be released easier and making it a strong acid because it ionizes even more and releases more H plus ions into the water upon ionization. And then finally, there's resonance, which also delocalizes negative charge and spreads out the negative charge because because it creates a partial negative charge between the atoms in a molecule. And so when you have different, when you have different when you have different atoms sharing a partial negative charge in a molecule, that's going to have a stabilizing effect because it's spreading out the negative charge. When you only have one atom having the negative charge, it will localize the negative charge, and that has a destabilizing effect. And that's not what you want for a strong acid. And so that's how all of those affect the acidity of an acid, the strength of acidity.